So hello everyone, I am going to give a presentation on the detection of breast cancer using machine learning models, and this project has been done under the guidance of our professor Anirban Bose, and these are our group mates. Uh, Let me select a laser pointer. Yeah. So we'll start with the introduction. We have to know that what is machine learning, what exactly machine learning is. So machine learning is a kind of artificial intelligence technique that teaches computers to think in a similar way how humans do, or maybe sometimes, or rather most of the times, they perform much better than what humans do. So this is a technique with which we explain the logic to the computer, and it works by exploring data and identifying patterns and involves minimal human intervention. And now let us come to its application. So its application, one of its application is in the detection of breast cancer, because as we know that breast cancer in India actually accounts that one woman is diagnosed every 2 minutes, and every 9 minutes one woman dies. So this is a very strange, but yeah, that's the truth. And if it is somehow detected at an early stage, then maybe with proper diagnosis and with proper treatment, we can save the lives of the cancer patients. So early detection is very important. So it is one of its application areas, or that is actually very major thing. So the method to detect breast cancer by employing techniques of machine learning, so we are going to explore that part over here. Okay, so we'll start. We have to take a data set, we'll upload the data set, and we have to clean it. So first of all, we'll import different libraries, we mount the drive, we have to load the data, and then we check, we perform all the data analysis part, and then we clean. If there are some missing values, we have to fix them. And this is how it behaves. And in our case, it is a binary classification problem, because either our target column is the diagnosis, and our diagnosis is either malignant or benign. So malignant means the tumor is cancerous, whereas benign means that it is non-cancerous. So it's a kind of a binary classification. So here we can see different correlation matrices have been plotted. So in our data there were almost 31 columns, 30 to 31 columns, and actually it is not possible for the user to enter so many data. So we have tried to find out those features which are closely related with with our target column, that is the diagnosis column. So for that we have plotted correlation matrix, and with the help of which we have identified the 12 most important columns, and we will be using those columns for the training of a model. Okay, so now we come to the cleaning and preparing the data. Okay, finally different graphs are plotted. The same thing, we plot a different heat map with the help of correlation matrix. Heat map for different correlation matrices are plotted, and these are all done basically to identify those 12 important parameters. And then if we come how to build the model, so first we have to specify the labels, we have to split the data into two subsets. One is training, and then other one is for testing. Then if needed, we do feature scaling also in the distance based algorithms. And then we come to the prediction of breast cancer using different machine learning algorithms. So in our case, we have used logistic regression, decision tree, random forest, artificial neural network, support vector machines, Knifewise classification, these six are used actually. Now let's get to them one by one. So in logistic regression, we did the training part. We have presented the confusion matrix of it over here. Then this is the ROC curve, and ROC, the significance of ROC curve is that more the area under the ROC curve, better is the performance of that model. So for decision tree, confusion matrix is here, ROC curve is here. Then the same for random forest as well, the confusion matrix over here, and then the ROC curve has been shown over here. For artificial neural network also the same thing has been done, and the ROC curve has also been shown over here. And then for support vector machines, the confusion matrix is here and the ROC curve is here. Finally, we come to Knifewise classification, and this Knifewise classification actually works on the principle of Bayes theorem. and confusion matrix and ROC curve have been shown here. And then finally we have tried to compile all of them so that we can visualize all the ROC curves at a single place. This is for logistic regression, decision tree, and so on. And in this slide, we are going to do a comparison between the various models. For example, we have compiled all the ROC curves of all the 6 models into a single picture, and from here it can be understood that the area is maximum under the ROC curve for support vector machines. So we can finally conclude that support vector model has the best performance over here, and so we are going to use it for the web deployment purpose. And so, hello everyone, I am Harshvardhan and I am going to speak on the conclusion, web deployment, and the future scope part of this project. Okay, so let us begin. Yeah, so we have compiled 6 different types of models in this project, and their accuracies have also been shown here. The first one is logistic regression, then decision tree, random forest, artificial neural networks, support vector machines, and Knifewise classification. As we can see over here that the accuracy is maximum for support vector machines, and also from the ROC curve of support vector machine we can understand that the area is maximum under this plot. So it's very clear that we are going to select this model for the purpose of web deployment. Okay, now let's go to the web deployment part. Yeah, so here is the web deployment part. What we initially did is that after making the model, we saved the model in the form of a pickle file so that we don't have to load the model again and again. And we have used Streamlit package for the making of this application. Okay, so as we can see, we have selected 12 features for this study. So they are mean radius, then mean texture, and the values have already been entered over here by me. And as we can see, mean smoothness, mean compactness, mean symmetry, mean fractal dimension, then standard error radius, standard error texture, and so on. And finally, here there is a predict button, and now we are going to click on it and let's see what it shows to us. Yeah, so it shows the patient has malignant tumor. So we can understand that this tumor is actually cancerous. So this is how the web deployment part actually works over here. Okay, so finally we come to the future scope part. The implementation of machine learning models in the medical industry will be a step towards ensuring the detection of diseases at a very early stage. The high efficiency in predicting that whether a person is likely to be diagnosed with a life-threatening illness might lead to a prompt attention from medical personnel at an early stage. We have worked with only a handful of data, that is around 560, compared to the total number of people affected with breast cancer in the past year. And as technology advances, it will be in no time when we will be able to store and process the entire data received from such patients all around the globe. This massive amount of data can be used to train models and predict future conditions of patients with very high accuracy. We have already learned that early detection of cancer is essential for the correct treatment. These types of predicting models will push boundaries in the field of cancer detection, and maybe someday we might even come up with a proper cure for this deadly disease. Okay, so finally, thank